Hello, students. This is Shakil, and today we're going to discuss AQA Physics 9630. And today we are going to solve some questions related to forces and momentum. I'm going to show you the specification for this topic, for which we are going to solve the questions. So here are the specifications which we have to do today. It's Newton's laws of motion, mainly applying F equals ma, and then momentum and solving its questions. So this is our target area for today. Okay, let me take you to the question sheet. So the topic is momentum and collision. So first, we will be intending to do the MCQs. Okay, let's look upon question number 1. In the first question, as you can see that this graph shows the force versus time for an object accelerating from rest. So the maximum force at 0 is 10. And the minimum force is 4 after 20 seconds. So what are they saying? What is the magnitude of momentum after 20 seconds? So we know this is force time graph. So we have a relation of force is equal to change in momentum over time. And if you do force into time, that will be change in momentum. So it means that this shows that area under FT graph, area under force time graph gives you change in momentum. So this is our equation that we have to use. It means we have to find this area. So let's find this area. That is 1/2 base into height, as it is triangle. 1/2 and base is this, which is 20. And height you have to take very carefully because it is not 10, but it is 6. 10 minus 4, because it is not 0, it is 4. So it is 6. So when you do this, you get an answer of 60 Newton second. So that's why you will choose this as your answer. Let's move forward to question 2. It's almost the same. It is force versus time, and this area is now seen to be trapezium. So this is the trapezium area, what they're saying. What is the impulse received by the object during the time shown? And you know what is impulse? Impulse is again the change in momentum. So this question involves your concept of impulse. So what is impulse? Impulse is actually equal to force into time, or it is change in momentum, or it is area under FT graph, because it's the same thing. So what you have to do is you have to find the area. So this is 1/2 sum of parallel sides into height. So the first parallel side is, let's say, this one, and second parallel side is this one. So either way is fine. And this distance between them is the height. So we say it is 1/2, 20 plus 30 into 4. So when you do this, 1/2, 50 into 4, so the answer is 100. So it means your answer is this 100. Okay, moving forward to question number 3. A glider X of mass 450 gram is traveling at 2.5 meter per second on horizontal frictionless air track. Okay, these are the frictionless air tracks. The holes in it are the places from where the air is coming out, and these are the gliders which are moving on it, and this air is making them move. And as it is shown that this is frictionless air track, so there will be no friction on this when the glider are moving. So the first glider X is moving to right with a velocity of 2.5. So you can say it is U1. The second glider, so this is M1 first glider, second, and the second one is at rest. So you can say U2 is 0. Okay. When during the collision, X continues in the same direction with a speed of 1.5. So this is after collision. and you would have to find what is the speed of y. So this is law of conservation of momentum. Law of conservation of momentum. It states that sum of the momentum before collision equals sum of the momentum after collision. So now 450 gram, you don't have to convert mass if you are using in this, because math is on both mass is on both side, so it is going to be cancelled away. So 450 into 2.5 plus this is u2 is 0, so no need to write this. And then again, this is 450 into 1.5 plus 250 into v, which you have to determine. So what you do is you just have to do the calculations and then you will get your answer. Okay, so when you do this, so your V answer comes out to be 1.8 meter per second. Like you have to solve this for this V. So this 1.8 meter per second is your answer. This is simple question. Okay, next is a firework rocket is fired vertically into the air and explode at highest point. What are the changes to the total kinetic energy of rocket and total momentum of the rocket as a result of this explosion? So when the rocket explodes, this is actually the explosion case. Explosion case. And we know that, let's say if this is mass m and it exploded in two parts, so this is M1, this is M2. So the two parts move in opposite direction for sure. Why? Because momentum is always conserved. So the total momentum of the rocket, unchanged, increases, no. Unchanged, yes. Increases, no. So it means that your two options are cancelled away. So you have to look for either A or C. And what about the total kinetic energy of the rocket? So we have to see that what has happened to the total kinetic energy of the rocket. Okay, so the total kinetic energy of the rocket is definitely going to increase, right? Why it is going to increase? Because inside the rocket there are chemicals as well. Chemical energy is there. So when the rocket is moving up, the chemical energy is still intact. But when the rocket exploded, that chemical energy is also converted into kinetic energy. That's why kinetic energy is going to increase. It cannot remain unchanged. Okay, next, what is the relationship between momentum P of the freely falling body from rest and its time? Okay, so you have to tell the relation between uh, momentum and the time. Okay, falling from the rest. Okay, falling from the rest. So it means that when a body over here is at rest and it is falling freely, of course, its momentum is zero. When it is falling, how its momentum is changing with time. So you know that momentum is equal to product of mass and velocity. So mass remains constant, but velocity constantly increases, right? So when velocity constantly increases, then we say that the momentum also constantly increases, because momentum and velocity both are directly proportional. So as velocity increases with time, so velocity increases with time. So time increases, velocity increases. So as velocity increases, momentum also increases. So that's why we cannot say that momentum is constant because velocity is changing. We cannot say that momentum is proportional to t1 by 2 because there is no such relation over there. Momentum is proportional to t. Yes, that seems to be it, because from here you can say that if momentum is proportional to velocity and velocity is proportional to time, then it means that momentum and time both are proportional as well. For falling body, as its fall time increases, its momentum increases. So this is the best option for it. We cannot say t square because there is no legitimate equation that we can use for this. Let's move to number 6. A body falls freely with negligible air resistance. Okay, negligible air resistance again means that it is free falling, acceleration 9.81. What quantity of body is rate of change of momentum? Well, that's easy. It's actually the weight. Why? Because we know that rate of change in momentum is equal to force. and force is only weight. Kinetic energy, power, mass, these are not the forces. Okay, now let's look upon this question. An object is accelerated um, from rest by constant force for time t, which graph represent the variation of time of change of kinetic energy and change in momentum of the object. Okay, so it means it started from rest and the force is constant. If the force is constant, then acceleration is constant. If acceleration is constant, change in velocity is also constant, because you know that acceleration is change in velocity over time. If acceleration is constant, then change in velocity is constant as well. It means it's increasing. Okay, so you know that momentum is product of mass and velocity. Mass is constant. So if this velocity constantly increases, momentum will also constantly increase. So when you look that this is the first relation, momentum and velocity are directly proportional. So it means that for momentum graph, it must be a straight line through origin. So it can be either A or C, because in A and C, both these lines are the straight lines, right? So this cannot be the option. So you have to look from A and C. Okay, now we have to look for the kinetic energy expression, that is 1 by 2 mv square. So it means that kinetic energy is proportional to v square. Now, as V is increasing, kinetic energy will increase twice because this is square. Like if velocity becomes double 2V, kinetic energy becomes 4 times. Why? Because this is V square. If speed increases 3 times, you need to take it square because V square is there. So kinetic energy increases 9 times. It means that both are directly proportional, but kinetic energy increases more. So here, in C, kinetic energy and time increases in the same way. So this is not the answer. Here, the kinetic energy is increasing more. So that's why our option is A over here. So A is our option. Moving on to the next one. And that is, again, the area under force time graph for a rocket. So you know the area under the graph gives you change in momentum. So which of the following is represented by area under the graph? So obviously it is change in momentum. Question number 9. A golf ball strikes a stationary golf ball of mass 4.8 tons per minus 2 gram and leaves the ball with a speed of 95 meter per second. The average force exerted on the ball is 7,800 Newton. How long the ball and club are in contact? Okay, so this is the ball and this is the, let's say, club stick, and it hits it with a force of 7,800 Newton, and it flies off with a speed of 95 meter per second, and you have to tell that how much is their contact time. So that's very easy. We know that force is change in momentum over time. So you replace time and force. So time is change in momentum by force. Change in momentum is mv minus mu over force. And now, as the ball was at rest, they said the stationary ball, so it means initial velocity is 0. So when initial velocity is 0, it means this is gone, and you only have to do this. So you have this mass, you have this velocity of 95, and you have this force. When you plug in the whole data into it, so you will get your answer as 8.5 into 10 raised power minus 4. Next question. Water of density 1000 kg per meter cube flows out of the garden hose of cross-sectional area 7.2 into 10 to the minus 4 at rate of 2 into 10 to the minus 4 meter cube per second. How much momentum is carried by the water while leaving the hose per second? This is a bit challenging question, so get ready for this and be attentive as well. Okay, so what you have to tell is that let's imagine this is the water hose, and the water is coming out of it, and the density of water is given, and then the cross-sectional area of this hose, this is also given, and then the rate is given. Rate means that for every in a time of 1 second, how much volume of water is coming out. So that is 2 into 10 to the power minus 4 meter cube is coming out. So how much momentum the water is having? So you have to tell that how much is the momentum of the water while leaving the hose over here. How much is the momentum? So we know that momentum is equal to mass into velocity. So you have already, do you have the velocity? No, you don't have the velocity. You don't have either the mass. Mass can be determined because you have density this. So mass is density into volume. So density is 1000 and volume is 2 into 10 to the power minus 4, right? So from here, 1, 2, 3, 4, it's 0.1 into 2 is zero point 0.2. So 0.2 kilogram of water is leaving the hose every second. So you know this. But the problem is you don't have this velocity. You have mass, you have not have velocity. So you can't use this formula. Let's move on to the next formula that in which momentum is there. So force is change in momentum over time, right? So this is over there. So we can try to do this as well. Okay, so first of all, we have to see that we have already done with this mass from density and volume. So let me just erase this to make some space available for working. So the water is 0.2 kilogram that we have already got. So the mass of the water is 0.2 kilogram that is leaving every 1 second. Now we have to see that if it is coming out from this pipe, so how much if the water is coming out, how much time it will take, like in 1 second, how much length or distance the water will take to move, and you have time of 1 second, and then we can use v equal d by t to get the speed. Okay, so in order to get this, we have volume as well and we have area as well. So you know that volume is equal to area into length. So volume is 2 into 10 to the power minus 4. Area is 7.2 into 10 to the power minus 4 into length. And when you divide both sides with this, so you get your answer for this length, right? So it is 2 into 10 to the power minus 4 divided by 7.2 into 10 to the power minus 4. And when you do that, you will get your answer for the length moved by this object, which is water in this case. Okay, so what you will do is after this, let me just erase this again for you. Okay, so we are almost at the end of our solution. You know that force is change in momentum over time. So over here, I was telling you that you can find the distance, and distance was 0. Um, let me check again, 0.278, and the time was 1 because they told that it is per second. So the speed is 0.278 meter per second. That's how you can find speed. This question is challenging because you have to find mass first by using density equal mass over volume, and second you have to find this speed by using this formula, volume is equal to area into length, and then this length can be treated as the distance moved by the water, and then the time is per second, so per second is like 1 second. So this is very challenging question. Okay, once you found that, so you can easily uh, get your change in momentum. In fact, this is the formula, but we don't have to use this. You know that the momentum is equal to product of mass and velocity. So you have found mass using density into volume thing, and both were given. And then you found speed by using this v equal d by t, where you found d by using volume divided by area, and time was 1 second. So that's how like you do it. So the answer was 0.056. So this is 1 2, so this is 5.6 into 10 raised to power negative 2. So B is the option. Question number 11. Well, a rail truck of mass 8,000 kg travels along a level track at velocity of 2.5 and collide with a stationary truck of mass 12,000. The two trucks move together at the same velocity after the collision. You have to find what is the change in momentum of 8,000 truck due to collision. Okay, so it means that this is M1, this is M2, this is U1, and of course U2 is rest. But once they collided with each other, so both of them stick together. So both of them stick together, and let's say they move off in this direction with a common velocity. So you have to find that how much is the change in their momentum of the smaller block. So it means that actually you have to find this as M1 V1 minus M1 U1. Like this is the final momentum of this 8,000 kg block, and this is initial. So when you divide them, subtract them, you can get the change in momentum. So initially we have the value M1 U1 because we have 8,000 and we have 2.5. So you simply multiplied that to get 20,000. So this is 20,000 Newton second is the momentum. Problem is you have to find the final momentum. What is the final momentum? And for that, you need to find the velocity because you know the mass, you know the velocity, you multiply them, and then you get your answer. In order to find velocity, we will be using this law of conservation of momentum equation. This equation you're going to use. So M1 U1 is how much? 20,000. And M2 U2 is what? It is at rest because that block was at rest. After collision, M1 is 8,000 V and M2 is 12,000 V. Of course, both have common velocity, so you add them. So it is 20,000 V. So this is also 20,000, this is also 20,000, this is gone. So it means velocity is 1 meter per second. It means both the objects have a velocity of 1 meter per second. So when you multiply 1 with its mass, it is 8,000, right? So it means that after the collision, this value is 8,000. This is 8,000 and initially it was 20,000. So now you subtract them. So the answer is 12,000. Okay, moving to next one. Which one of the following is the possible unit of impulse? That's quite simple. Impulse is actually momentum. Impulse is momentum, which can be mv, which can be force into time. So if it is mv, so it is kilogram meter per second. If it is this, so this is Newton second. So these both are equal together. Kilogram meter per second or Newton second. So here you go, kilogram meter per second. Next question. The graph shows the resultant force F acting on the block varies with time. What is the change in momentum of body over the 5-second period? Like the whole 5 second. But the problem is as it is area under the graph, so you will be only doing this. Okay, so you have to find area under the graph. So 1 by 2 force into time. So 1 by 2, how much is the force? 4. And how much is the time? You have to look for how long the force acts. But the problem is this is actually not a triangle. This is trapezium. You can say this is the trapezium. So that's why we have to use the 1 by 2 P1 plus P2 into T. So 1 by 2, this is P1, which is 3. 4 minus 1, this is 3. This is important. And then this is P2, which is 2 and 4. Like here is 4, here is 2. So this is 2. And then the next thing is this height actually. So height is 4. So it means that this is 3 plus 2, 5. 5 2s are 10. So 10 is the answer. So actually, you only have to use that area under FT graph. Area under FT graph gives you change in momentum. And the trick can be the area shape. Area shape can trick you. Okay. Question number 14. A gas molecule of mass m moving at velocity u collides at right angles to the side of a container and rebounds elastically. Elastically means there is no energy loss, right? No energy loss. And that is ideal collision. Which one of the following statement concerning the motion of molecule is incorrect? It means three are correct and one is incorrect. The magnitude of change in momentum of the molecule is zero. Look, first we can draw the diagram. It is moving with m mass moving with velocity u. When it collides elastically, so it rebounds with the same velocity. So we know that anything moving to initial direction, its velocity is positive, and while it is moving in opposite, so its velocity is negative. So this is negative. So change in momentum is mv minus mu. So the mass is m, final velocity is minus u, which is over here. You can say it is minus u, so you have to put minus u. And then the initial velocity is u. So this is minus mu minus mu. So this is minus 2 mu. So change in momentum is minus 2 mu. And remember, this negative sign is just part of direction because it is vector, na? Momentum is vector. So in vector, the negative sign only shows the direction. But if you want to find the magnitude, how much is the magnitude of change in momentum? So that is 2 mu, which is known as magnitude of change in momentum. So that's why the first one is wrong because they're saying the magnitude is zero. The magnitude of change in momentum of molecule is 2 mu, spot on. Well, brilliant. We already discussed this, that the magnitude of change in momentum is 2 mu. Okay, a ball is released so that it's fall vertically. Okay, every freely falling body falls vertically down. The resultant force acting on the ball changes with the time. So this is the force which decreases exponentially with the time. Okay, it means some, as this is resultant force, so it means air drag will be there. This is the ball, its weight is constant, right? But as it is moving down, the air drag acting on it keep on increasing. So as a result, this net force is equal to weight minus air drag. So we say that this air drag is constant. The weight is constant. It's never changing. But the problem is this air drag keeps on increasing. So it means that the resultant force will keep decreasing. That's why this is the trend of the resultant force. Now they are saying which of one of the following is represented by area under the graph. Well, that's easy. Area under the graph, and this is force time graph. So we know it is change in momentum or it is impulse because both are same things. So not distance, kinetic energy, acceleration, it is impulse. Okay, next question. A cricket ball of mass 0.16 traveling at speed of 35 meter per second is hit by the bat and as a result of this impact leaves the bat in opposite direction at 30 meter per second. If the duration of impact is 52 millisecond, what is the magnitude of average force on the ball? Well, I hope every one of you likes cricket. Yesterday, Pakistan beat Australia by 9 wickets, and that was a very thrilling match. I just managed to see the highlights for that. Okay, so there are two things. Like one is the bat, and the other one is ball. So this is M1 and this is M2. So this M1 is 0.16 kg and the ball mass, we don't know. Okay, no need to know that if it is not given. Okay, so the bat is traveling at speed of 35 and the ball. Oh, sorry. Well, I have choose the wrong values. This is 0.16, sorry. The ball mass is 0.16. Well, it's 160 grams. So yeah, bat cannot be a 160 gram. Okay. It is traveling with a speed of 35 meter per second. Of course, the bowler has bowled the ball and then it hits the bat and as a result of impact, the ball leaves in opposite direction. So after hitting it, it of course leaves in the opposite direction over the head of the bowler and going to the boundary with a speed of 30 meter per second. So their impact time is 52 millisecond. Yeah, that's very short. You must have seen that when the bowler hits a 6 or 4, we can't see that at what moment the ball was hitting the bat, because that moment is very, very short moment, because both ball and bat are hard. So hard bodies contact time is always smaller. So what is the force acting on the ball? So force on ball is like change in momentum over t, obviously. Like that's how you can find that. And the change in momentum is mv minus mu, right? This is That's how you can find the change in momentum of the ball. And as both the velocities are given, so you can easily find that. Initial is always taken as positive, and then the final is opposite, so you take it as negative. So the ball mass is 0.16 and final velocity is minus 30 minus, or you can do one more thing, sorry. Right side is positive and left side is negative. So you can do that as well. That's not a problem, right? So this is plus 30 and then 0.16 and initial velocity was minus 35. So now what you do is you solve it. So the change in momentum is of the ball is 10.4. This is very important. Again, change in momentum is very important. You have to take left side, right side of the movement as positive velocity, left side as negative, whatever. You can change that as well. Like in one direction, velocity should be positive, in another direction, it should be negative, and carefully putting that. Even if the change in momentum answers come with negative, you can ignore this negative because this is part of direction, not the magnitude. So that's why whatever direction of velocity you take, positive or negative, that's completely fine. Okay. Finally, what you do is you found change in momentum, which is 10.4, and the contact time is 52 millisecond. So when you solve that, you get the answer of 200 Newton. So that's why this is your answer. Okay. Let's go on this question number 17. A ball of mass m traveling with velocity v collides normally with a smooth ball. As shown in the figure, okay, this is m, this is v. So its initial momentum is mv. This is its initial momentum. Okay. Which line from A to D in the table gives the correct expression for magnitude of change of momentum after and change of kinetic energy of the ball? Okay, anything given? Yeah. And rebound elastically. Elastically means that when it is rebounded, its velocity remains the same. The only thing is you put a negative sign over there because right side is positive and left side is negative. So this is the same question we have done two times, a couple of times. The change in velocity is zero. Why? Because in elastic collision, there is no loss of kinetic energy. So this B and D are gone because there is a condition that if it is elastic collision, then the change in kinetic energy of system is zero. No kinetic energy changes. And the change in momentum is 2mv. How? Change in momentum is final minus initial. So final is minus V and initial is V. So this is minus MV minus MV. So this is minus 2MV. So again, negative sign ignored because this is part of direction. So the magnitude is 2MV. Okay, again, a very easy question. A mass of 2 kg initially at rest, and this is the force which acts on it. The force, of course, varies from 0 to 10 in 4 seconds and then decreases in the next 4 seconds. What is the velocity of the ball after 8 seconds? And the ball was initially at rest. Okay, that's perfect. So you know that the area under this graph gives you change in momentum. So this is half base into height because this is triangle. So this is base and this is height. So we say that this is 8, base is 8 and height is 10. So it means that this is 40 Newton second. So change in momentum is 40 Newton second. Now, you know that change in momentum is final velocity minus initial, which is 40. As initial, it was at rest, so that's why 0. So finally, it is mv is 40 and the mass of the ball is 2 kg. So you just shift 2 to the other side. So this is 20 meter per second. So at the end, its velocity is 20 meter per second. Moving on quickly to the second last question for today. Two ice skaters initially at rest in the contact push apart from each other which line table shows the change in momentum and the total kinetic energy of the two skaters. So initially at the rest and contact and pushing to each other. So of course, the momentum is again unchanged because that is the law of conservation of momentum. Like momentum never changes, right? So momentum will always remain the conserve. Okay, so okay, so we can say that yes, this option is there. These cannot happen. Why? Because total momentum always remains unchanged, right? So as the skaters were at rest and then they push apart, so obviously first they were at rest, so their kinetic energy was zero. And when they push apart, they start moving. So their kinetic energy is no more zero. It means kinetic energy increases. So A is the option for this. Okay, the last question. Which line A to D in the table shows correctly whether the moment of force, momentum is a scalar or vector quantity? That's very easy. Well, the last question is easy. That's a great thing, a great sign. Moment of force. Moment of force, of course, is vector because it can be either clockwise or anti-clockwise, and momentum is also vector because, yeah, it is having velocity. So now carefully look upon it. You can stop the video and you can solve the question. And I will be providing in the description the answers for these. And then in case if you come up with anything that you have to discuss or you are not sure about how it is solved, then you can approach me in the comment section and I would love to help you out because all of these questions are pretty much similar to the ones that we have already done. So these are the all questions for AQA Physics, and this is for Unit 1 or Year 1 exam. And these cover momentum, law of conservation of momentum, and impulse. So here you go. So these are the questions. Well, the answer scheme is also there, so you can watch answers from here as well. Okay, thank you, students. I hope that this session must be the informative one for you. So watch out for the next video, and that is about the theoretic questions about momentum and force. Until then, take care and study hard.